Hello, everybody. So, up to this point, we've talked about derivatives for functions of several variables. So, our next step is going to be talking about integrals for functions of several variables, which, as you know, it's possible to take the antiderivative of something pretty easily. But we're always doing the antiderivative with respect to a certain variable. Therefore, it gets more difficult when you add in a second or a third variable. We'll only fully focus on situations of two variables, but it still has some nuances to take into account. So that's where double integrals come in. Well, what's a double integral? It's something that looks like this. So it has two integrands in the front, two sets of bounds, and two infinitesimals, or the dx, dy's at the end. All right. So this might look really intimidating. Don't be intimidated by it. It's really straightforward. So you want to view this as two separate variables, or two separate integrals, like this. So you have an integral on the inside, and then you're taking the integral of that. All right. Now note, the order of the dx and the dy does matter. If you are given dy dx instead of dx dy, it will be different. All right. And the bounds are associated with that variable. You have to be very careful about this. All right. So that's probably somewhat confusing just saying it. So let's run through a quick example. So our two integrands, our two sets of bounds, our dx dy, and our function is in the middle. Now note the 3 to 4, that means x is going from 3 to 4. The 1, 2, well, the outside is y, so y is going between 1 and 2. So that's just a small box area that you're integrating over. All right. We'll get more into class about that later. So how do you do this? Well, again, you separate out each individual part. So you just look at this and integrate this. Again, same with when taking the partial derivatives. If you're not taking the integral of the equation with respect to that variable, it's treated as a constant, so it just stays put. So when you integrate this, it's just x times a constant. Constant stays put. Add 1 to the exponent, divide by the new exponent. Then you put in your top, put in your bottom. There you go, and evaluate it. All right. So that's going to give you some amount of y's. So that gives you 7/2 y. And when you do this out, well, that's now just a basic integral in terms of y. All right. In general, when you are doing double integrals, the original variable should always cancel out. Shouldn't be there anymore when you go on to the next stage. All right. There are very few cases where this will not be the case, but we won't be encountering them for this class. All right, so let's go and give you an exercise to try out. So I want you to find the solution to this double integral. All right, if you're having trouble to start with, remember, put the parentheses around and just view it one integral at a time. And keep in mind, for the inner integral, y is just a constant. All right, hopefully you've tried that out. And you should be able to integrate it and get it something like this. I'll go ahead and input your bounds. All right, hopefully you've done that. And if you didn't, here is an example. So you should have this. Now just integrate this. Should be pretty straightforward. Here it is in case you don't know yet. And it should come out to -1/2. Keep in mind, since there are bounds, this is a definite integral, so no plus c. All right, hopefully you learned something.